Hello, I am Juan, and this is a new video following as a follow-up to my last video introducing some of the foundational principles of this company, Torbellino Tech. In this video, I want to comment a little bit on some of the things that I was talking about in the last one. Add some further notes, some commentary to help a little bit the audience understand better the relevance of the ideas that we are trying to present and to bring forward in this company, the ideas from which we start, the power of those ideas. And in order to do that, of course, we have to, we are just starting, so we have to study what's around. We have to understand what is what has been done and what people are doing. I have been doing this personally for a while already, for years. I have studied, and but we have to keep doing it. And of course, we are starting from very humble beginnings. So um, we have to appreciate, at least that's also how we understand this field of artificial intelligence. We understand that there is a history, even if it is. We will talk about that. Actually, I was talking about that in the last video, the history of the field, even if it is. Well, it depends how you approach it. We could say the most obvious approach is that it is a quite young field, let's say. This started just the last century, like maybe 80 or 100 years ago, relatively speaking, when we are thinking about the history of science in general. We think this is first of all a scientific endeavor, let's say, and of course then there is an engineering. There is the science implies also the possibility to build systems, to find real applications, like any science. Really, it happened with physics, it happened with chemistry, it still happens. And the thing with science is that it is more universal, right? Uh, the applications are more universal also. And so in this uh, uh, vein, I wanted to talk a little bit more about what is going on, to also again to help a little bit understand how can we maybe how is this company relevant, what are we proposing. This is something that I will try to explain over the course of, I don't know, maybe a few videos. I don't know if it's going to be many, or honestly, I don't know right now. But I will try to do it also in other forms. But I think this is one of the methods. I mean, I'm trying it. I am testing what happens. And so here we are seeing Nvidia is a very relevant company in this field. Of course, you probably know it. Probably everybody knows it. If you don't, I don't know. Maybe look at uh, some some social network, or look at the news, and you'll probably see it. And yeah, it's probably the most important company in terms of the universal impact it has had, and they are pushing really this idea of artificial intelligence. There are many other companies, of course, many companies that have been working on this, some of which you probably know also about, others that maybe you don't know. Many companies that are new, many startups, many small companies are embracing this concept, which to a certain extent is just a term. I mean, there is some commercial, some simply commercial. Many companies also are just maybe using the term, or they are trying things, which is fine. But there is also just this hype, let's say, of course, around artificial intelligence. And one of the things about artificial intelligence, I think, one of the things about I talked about it before in the previous video, is that it is a powerful concept because it is not that clearly defined. That's also the reason why there are probably many companies, among others, of course, among other reasons. But one of the reasons why we can have many different companies, and there is this a lot of movement, let's say, in this field. I think it is precisely because of that, because this concept is not very clearly defined. It is open-ended, and so there is room for interpretation. There is room for perspectives, I think, and there is room for diversity in terms of the companies that appear. And so different companies propose different applications. For example, right? They supply artificial intelligence to healthcare. They supply artificial intelligence. Maybe this is one way to classify the companies, right? In terms of for example, one, I think it's an interesting, in terms of an interesting first approach. Maybe the most obvious approach is to classify companies. You classify them based on what is the sector of the economy that you are applying artificial intelligence to. It is, I think it's useful, it's relevant, and you can see many companies also in this under this criteria. You can find many different companies. There are maybe other criteria you can use, and so Nvidia is like let's say it's a little bit in the middle and everywhere of this artificial intelligence. It is a core, it is an infrastructure, first of all, right? Infrastructure, it's semiconductors, it is hardware, but it is also software. They are a little bit everywhere in this. It's a big company. They can do that also because it is already a very big company, right? It is one of the biggest companies in the world, right? I mean, depends how you measure it also, but and so of course it is. We have to talk about it. We have to appreciate not only of Nvidia, but maybe the most clear example. We have to appreciate the contributions, the achievements, of many people that are behind the company, and we have to study what they are doing, and maybe try to build on that. Many people are building. Pretty much everybody, we could say, is somehow. I mean, there are, it's not a monopoly, strictly speaking. I think there are some alternatives, but pretty much everybody is building something on top of this, or somehow related to it. And so, of course, we in this sense we cannot be special. We can be special in other senses, and I will talk about that. So NVIDIA here. Even if it is, we could say NVIDIA has already is already a very under pretty much every criteria you could. I think it's undeniable that this is a successful company, right? Who could doubt that? But still, this concept of artificial intelligence, we are only in the beginning, and in fact, they know that and I think it is not just that they are interested in saying that. I truly think that they think that, and I truly think that this is the case. That this is just the beginning of a new era, golden era of artificial intelligence. But of course, that depends on many things. Depends on, I mean, it's open-ended, so depends on whether or not we are really willing to embrace the implications of this concept as a society, as the different companies, the different people. Depends on our work, our dedication, our commitment to this concept, which has I think it can have deep implications, right? I mean, many people are seeing that, are talking about that, and so I think it is an open-ended concept, and it depends. And I think it can, if in the optimistic scenario, let's say, for those that want to see how the implications, to what extent we can, let's say, bring this concept, this idea forward. In the optimistic scenario, I think we are just in the beginning of this. And so, having said all of this, so I wanted to say, so again, well, maybe one way to understand a little bit how did they do this, right? How is it possible that this company has become so relevant? This company has had so much success. Well, one way to look at it is to look at the people, the particular people that are behind it, and to look at the education system. In this particular case, I think, again, the education system, the scientific, the maybe look at it's a first way to approach it, but I think it is relevant to look at what the people study, the institutions, the scientific and education institutions with which the people in this company have been related. And the CEO of the company, and probably many others, I mean, it is not it is not surprising, I guess, that the CEO of the company, and again probably many other people in the company, are coming from Stanford University, one of the most popular, famous, prestigious universities in the world. And Stanford University has different programs. I've been looking a little bit the offerings of this university. I mean, I have known this university for many years already, of course, but I for this video I've been specifically looking at what are they offering today, because in my previous video I referenced a book which is as I said, I mentioned in that video, it is a very it is widely accepted, and it is widely referenced, it is widely used in many pretty much every undergraduate, and also in maybe some graduate courses, they reference this book. It is a manual, a standard manual the book from Russell and Norvig, Artificial Intelligence: A Modern Approach. And here I came to do this. They offer different programs, and I came to the first one I saw, which is this one, CS221, Artificial Intelligence Principles and Techniques. And I came to the references. I didn't know really, but not surprising, as I was expecting it, but yeah, exactly. Again, the first reference is that the same book I was referencing. It's not surprising to me. And so they also reference many others, but the point being that this course that is still going, right? They are doing a 2024, autumn 2024. So last year, this book has. I don't know that the first edition of this book maybe was published in early 2000s or something like that. But 20 years have passed. Maybe there are different, of course, there are probably different editions, but the book is still relevant. And there are many other reference here. It's just a starting point, but so I wanted to maybe update a little bit, right, and to stay just to comment, to make some comments that are the what we are talking about here, the points of reference we have, the reference institutions, our understanding of this field is relevant. And so if we take this course, I was looking a little bit into it, and I looked at the modules here, and I think this is a pretty standard. I also took some courses on this, on artificial intelligence, when I was in my undergraduate and graduate studies. And basically the program of the course has remained in the last I don't know, maybe last decade or even 20 2 decades, 20 years. I think it has remained pretty much the same. Not a lot has changed, I think. And in terms of how when we talk about the principles of artificial intelligence, right? This course is about the principles and techniques. Here we will be talking a little bit more about the principles, but here they talk about principles and techniques. It's also in the title of the course. There is also already it makes sense because also because of the way these people understand artificial intelligence. We will talk a little bit about that also in a moment. And so here, but I got when I was during my graduate studies, I got pretty much the same. We will have to look at the contents, but I think if we don't take into consideration the subtleties and the different style of the professor and whatever, I got a pretty much equivalent treatment of this matter. Basically, I studied in a Spanish university, by the way, but the program I think is pretty equivalent without taking into consideration the specificity of the institution. And so here the first module is about the history. They talk about the history. This is pretty standard also. I think the history is important in to understand where we are coming from. In a certain sense, science is the history of education. You can think about it like that. Science is the main way to let's say move knowledge across time, across eras, right? It's the most the most probably the most. There is progress. There are changes, but probably science is the most conservative in the positive sense of the word, in the sense of solid, the most solid type of understanding of knowledge, right? I think universities have to do science probably better than they are doing it. I'm not talking about in particular. This is a more general commentary on the state of universities and the education system. But anyway, so probably among all the histories, the history of science. I mean, history itself is not a science, but among all the histories that you can make, maybe the history of science is the best one, because it is. I mean, it's the most boring one, probably also because maybe not a lot happens. Well, in the case of artificial intelligence, the history of artificial intelligence is short, we could say, relatively speaking, but there is some history. And here they have. So I'll be looking a little bit about this history of. Here they dedicate one session, some slides to the history of AI, and they say some interesting things. Again, this is I think it's a pretty standard approach to the history of artificial intelligence. I was talking about the history of artificial intelligence in the previous video, and in fact, there at the end of the video, I announced, let's say, or presented, or made public there my lecture that I am offering. In this case, I am offering it as a product that I am marketing, that I am selling, and a closed product, and it is a lecture about the history. So I have a particular view on the history of artificial intelligence. I have in fact, I have a thesis of the history of artificial intelligence, and in this lecture I present that thesis. And here they have they talk about the history of artificial intelligence, and we will see they don't really, they have a thesis, but what do they say here about the history of artificial intelligence? Look a little bit about these slides and at the slides, sorry. And so first of all, what I can say about this I think it is a pretty standard approach. Let's say what you can see in pretty much any university and in this context, this type of course maybe. There is we have what we could say, what I could name as a typical historiographic approach for the most part, which means, but basically we have it is just a lecture and I haven't heard what they say, but because of the conclusion also of the slides, I think it's quite clear. We have basically a series of more relevant events. We have some big names in terms of people, and also some some let's say inflection points, right, or some main events that somehow help us understand a little bit, structure a little bit what we have seen in these years, this maybe 80, 100 years. There are some references, interesting references to, but very briefly touched upon some references to ancient, quite before the 20th century. But anyway, there are, what I was saying is it is basically a historiographic approach, which means basically a series of events is presented but there is no in principle. I mean, you can see the slides. In principle, first of all, there is no there are no principles to approach. What I'm trying to say basically is that there is no principled approach to the history. So when we talk about, coming back to the title of the thesis, sorry, to the title of the course, here we have artificial intelligence principles and techniques. And of course, this is I mean, I understand this is a course in computer science. So I think it is not, I mean, it is justified, and we cannot ask, not necessarily, from this course that we have a principled approach to history. But I am using the course because it is, so I'm not trying to criticize the course in this particular point, because it is not something we can ask from this particular course. But it is an example for me to differentiate, So we cannot expect, so of course they talk about the principles of artificial intelligence, not about the principles of the history of artificial intelligence. So they approach the history of artificial intelligence, but they don't approach it in a principle approach. However, the problem is that there is some, maybe it is not a thesis, but there are some conclusions, of course, here in the slides, and there is a thesis, actually. There is a maybe implicit thesis. I think it is quite a strong one, actually. So here's the problem, right? Anyway, I think it is reasonable, unreasonable approach, but anyway, I'm trying to claim something here, which is that I think that there is a better way, even if it is just some slides. I think there is a better way to approach the history of artificial intelligence. Not to criticize in particular this course. This is just an example. Okay. But I am anticipating things. So, but this is a historiographic approach, right? This is not a principled approach in that sense. This is what I was trying to say. There's also I think it is maybe a literary recourse. This is something. I mean, there is some foundation to it. Maybe if you bring it to a meaningful conclusion, let's say. But there is in this case maybe it is. I think it's more like a literary recourse, a typical literary recourse, which is a literary figure. I don't know if that's the English term in particular. What I'm saying is that in this presentation there is an element of dialogue. There is a dialogue between well, I'm jumping a little bit, but there is a dialogue between the three, where we are seeing here basically the three different perspectives. Then we will see two perspectives that are opposed, and that also allows to present a little bit of a story, maybe more than a history. But I mean, there is a history, but there is this dialogue between the different. There is the symbolic approach, the expert systems approach, or the knowledge-based systems approach. There is the statistical. There's the neural approach. The approach based on the biologically inspired approach, let's say, in particular in neural networks, biological neural networks. And then there is a certain, the author of these slides, with some foundation to it, we should say, but also in a sense of in a certain literary recourse, there is a dialogue, right? There is a certain opposition between these approaches. So this is a little bit the way this is presented, which again, to a course that is not about the history, strictly speaking, about the history of artificial intelligence, is perfectly acceptable. But we are going to say a few things about this, a few meaningful, relevant things about this. This is going to serve in this video as a way to differentiate, although I'm not going to introduce really a thesis, because that is I might do that in a different moment. in this video I am adding, I am specifying, I am trying to go a little bit more precise into what problems or what deficiencies, what incapacities I see, or what imprecisions or inaccuracies I see in this approach. So first of all, again, this is not a principled approach. This is more to maybe to clarify a little bit the point I was trying to make before. This more than a history, let's say, we are here seeing a story, which by the way it's interesting because in Spanish we don't really have syntactically or there is no word really. We talk about historia, and we use the term historia both for story and history, but in English you have you have two terms, and that is useful. So here I think we have more a story than a history. To maybe to explain a little bit, to I will say a little bit more about that later. So here, what can we say also about? Yeah, I already mentioned there is this dialectical. So what is the problem? For example, this. I mean, we can see that in there is a conclusion. There is a certain, let's say, optimistic or a harmonic conclusion to this lecture, in the sense that at the end of the day, so here we have the different approaches, right? That they are presented a little bit first, like they are opposed a little bit. There are some difference there. Yes, for technical reasons, for example, yeah, and that is coherent with the title of the course and the philosophy, let's say, of the course. I think this is let's say a good point we could say about this lecture. There are, for example, when we differentiate between when the author compares the knowledge-based systems with others, they say that there was a technical problem in terms of the scalability of the systems because they required they were hard to kind of like there was some craftsmanship, let's say, there when building the system, so they were hard to scale in that sense. Also on top of that, well, I mean, there are comparisons also with the lack of data. So here knowledge-based systems, because of that structure, were able to sort of alleviate the lack of data, the lack of information in this era of informatics, let's say. But on the other hand, they were hard to scale because of the craftsmanship required by the engineers, right? And so there are comparisons like that. There are comparisons between the symbolic, the knowledge-based systems, and then the artificial neural networks. There are, as I said, here we find some events, right? Some let's say let's points in terms of. There is another important thing here in the history, which is, yes, two things maybe, the names, the important names, right? I mean, this is typical. Well, of course, where we have in a typical historiographic approach, we have the big names of the big names, the people, the scientists, the engineers that were the main contributors to this field, this story, and then we have the dates, and we have the models also, and the algorithm model or algorithms, right? And we have again technical, mostly technical, or we have some comments regarding some technicalities, right? Like I said, like about the scalability, about the performance of the models, and so on and so forth. And here the statistical they start talking about the statistical approach, and the neural networks goes to the deep learning paradigm, let's say, with ever growing, let's say, or bigger and bigger artificial neural networks. And here we have again the mentions to performance, the different models again. We have references again to big names of the field, people, institutions, companies, of course. This is when big tech appear, right? Here I was talking about Nvidia before. Here we have many other companies that were really important and are still, although Nvidia has is more popular now, more recently, but Microsoft, for example, Microsoft or Google were equally or maybe even more important under some criteria. For example, when it comes to some foundational models or techniques, more in the software domain, right, than Nvidia. There are, and again, mentioned to other models. There is an opposition between the symbolic. There is certain. So we have these oppositions. Again, I was talking about this kind of dialogue between the symbolic, for example, and the neural AI. There is also here. They name different models. One of the main fields that influence that is kind of where artificial intelligence comes from is mathematics, right? We have here all these models. They are mostly represented as, or either as in the symbolic, as maybe more logical models, or mathematical model, different branches of mathematics, linear algebra, of course, or graph theory, or so we have all these things, right? And here we have the three main intellectual traditions: symbolic, neural, statistical. And so the main thesis basically of the so there are some implicit things here. So let's go back to for example, the beginning, which is mentioned in this article by Alan Turing. I also mentioned it in my video, also pretty much in the beginning of the video. And so there is a comment here, a commentary here about these two approaches. There's also this opposition between the let's say the symbolic approach and the maybe more the biologically inspired approach, with the analogy of the children, or of the child here. And the thing here we can say here, a commentary I can say, a note I can add here to this slide, is that in fact at the end of the day, even if in this paragraph and the author, Turing in this case, says that both approaches could be tried, maybe more we have two approaches basically here, the formalist approach and the biologically inspired approach. At the end of the day, the approach and the contributions, the main contributions that this author made, which are fundamental in this history, the main contributions are more on the symbolic domain, right? The biologically inspired domain, it is true that there are some references here, but in fact, for different reasons, there are also further commentary in different points of the text. But I think this author in particular is bending more, not only because of the the contributions that he made, but also here in this in other articles, in other works, of course, but also in this particular article, there is, I think the author is a little bit more to the side of on the side of the formalist approach or the symbolic, which is not exactly the same, because symbolic is more specifically regarding artificial intelligence and an approach to artificial intelligence, a subset, let's say, of artificial intelligence. But the formalist approach is more a philosophical approach, and or a methodology of science, maybe, because this article is an article of methodology of science. And in terms of methodology of science, we can say, and this has been said, it's not something new, that Alan Turing is more a formalist. And the way Alan Turing understands, so we can also say that there is when we talk about the philosophy of the mind, the formalist approach. Say, I'm not an expert in this branch of philosophy, but it is not incompatible. You can talk about psychology. You can have a philosophy of the mind and be a formalist at the same time. And I think this is a little bit, so just to clarify a little bit here, I think it is relevant. So Turing was more a formalist. The biologically inspired trend, let's say, or branch of or scientific community of artificial intelligence came after Turing, and here there are some names, some big names also. It is also referenced a little bit, more into the presentation, of course. There are, so basically, I think, so mostly, I mean, one of the big names is Rosenblatt, I think, if I'm not mistaken here. So with the, yeah, exactly, in 58. So this is, Alan Turing is already dead at this point, I think. And so it's closer to our, it's later in this history. This is a major, the perceptron algorithm for linear classifiers is like the this is pretty standard. It's like the beginning. I mean, okay, there are some other dates here. Yeah, you could argue. Sure, but basically here is the starting point. Let's say this is pretty standard, the starting point of artificial neural networks. So, but anyway, when it comes to, for example, so I already talked a little bit about the principles. I introduced a principle. It's just a commentary, but I think it is relevant, that Alan Turing is more a formalist. When we look at the history and we have to classify, let's say, this work, in particular Alan Turing. There are many other people that have had this approach. We have to say that this is a formalist approach. Basically, what is defended, let's say, here at the end of the day. And another thing we can say about these artificial neural networks, or the biologically inspired branch of artificial intelligence. First of all, we have to say that this is, of course, an example of an analogy, as it is, as it was presented, first of all, and as it is understood. Mainly, we have to understand it. Still, maybe, I don't know, maybe there are some developments, but for the most part, and I think this is the origin of this branch. This is a reasoning by analogy, so it is biologically inspired. Of course, artificial neural networks. Well, what I'm trying to say is that there is a gap there, because we are comparing silicon-based entities, the computer, the digital electronic computer, and neural networks. Well, I mean, neurons, which the neuron is a originally biological, and strictly speaking, the neuron is a biological concept. There is a gap between these two fields in particular. So there is a model, and this is not in contradiction with not exactly in if we are completely neutral and we stay in the formalist domain, let's say, we can accept this analogy. Even we, I mean, the analogy is also a literary figure, right? And we can, yes, we can present a model as a graph, a symbolic representation, maybe, or mathematical. You can represent a graph like a matrix, of course, and or anyway you can have any different mathematical representations, and you can present this model. And this is not as long as you are honest, let's say, and you stay in that, you accept those principles and you stay inside of them. But this is what I'm trying to maybe make more explicit here about this presentation, right? That is why I think maybe we have to comment on this presentation. The formalist approach of Alan Turing is not, strictly speaking, in contradiction with artificial neural networks, as long as you understand that artificial neural networks are presented as a case, has to be understood here as a case of analogy, reasoning by analogy. It is a branch that is biologically inspired, but strictly speaking, from a scientific point of view, in terms of what the neuron is, there is no grounds for this. As it is presented, then there have been many studies, and I'm not going to talk about that because that is a whole branch of. I'm talking here about the origin, how this model is presented. Then there have been many this inspiration, this biological inspiration. It is I'm not claiming the opposite. This biological inspiration might lead to further developments, further discoveries about, I don't know, the properties of silicon and the properties maybe the cameras and the properties of biology and the properties of the graphs and so on and so forth. I don't know exactly. I don't know about that. You can go into that field. But I'm talking here about how this is presented. This is presented, first of all, as a biologically inspired model, as an inspiration. And this is, I think, this is widely accepted, independently of other discoveries and developments that have probably happened. I'm not an expert in particular in this sub-branch of artificial intelligence. But that is one thing I wanted to clarify, that this is important, right? It is very important to emphasize this, that artificial neural networks is there's an element here of reasoning by analogy, which is not in itself something bad. It is again, in principle, it is consistent, coherent with the formalist approach. It doesn't contradict directly this approach, but it is this type of understanding, right? So basically, what deep learning, what we have had with deep learning is, now we have this original perceptron model. We have basically built. You can represent it. I mean, this is how it is represented, as a graph, as a mathematical. You have a mathematical representative, and then you can build different. You can put so many layers. You can put billions of or millions of neurons and connections and billions of parameters and so on and so forth, and you get different architectures with that might be more or less inspired, more or less accurate, let's say, under that analogy, let's say, and well, you can have that, and this is deep learning, which has led, in terms of performance and in terms of results, in terms of solving tasks, in terms of those applications, the real world applications. This has led to some of the most surprising, some of the most performant AI systems, if not the most. with other things on top of that. Now we have, I mean, this is again from maybe 2012. Here we have again another AlexNet is a major event here in this history in terms of the scalability, right, and the types of the complexity of the tasks. In terms of also here we have the benchmarks, right. This is another point I wanted to emphasize. Because this is a way to, but I wanted to emphasize a way to approach the history of artificial intelligence is, this is maybe the most obvious way to do it. I'm not saying this is something bad, but this is one way to do it. Okay. Of course, to look at the names, the people. This is pretty much, you can find it in every history of everything, pretty much, and in particular science. You're going to have. This is the most typical way. You have the big names, right? The big names. This happens in physics, happens in chemistry. The big names in terms of people, in terms of institutions. Yeah. Of course the dates, right? But in particular here we have also another thing, which is the models. So for example, AlexNet or AlphaGo, or I don't know, the perceptron model. We have the systems or models, AI systems or models. This is a particularity of this history. It is also one way to understand the history of artificial intelligence. You don't have that in other histories. Or inside science, maybe you have other concepts, we have other things, but in artificial intelligence, the models, as it is understood mainly, in particular in this trend of deep learning, which is the major force here, the major way to understand artificial intelligence, because of the performance, because of the benchmarks, because of the scalability of these models, because of the methodology. This has been the methodology that has had more success, mainly in the last decades, and probably, yeah, of course, in the history, which is relatively short, nevertheless. Now we have other topics on top of that, of course. Since 2012, many things have happened, and so there are things, people are doing things on top of that, different things, talk about the reasoning, about the planning, about, but this is still the main topic, right? And so, but I wanted to emphasize again, just to clarify, this is important when we look at it with perspective a little bit, and also when we want to look at the future and also the present. Actually, I'm going to comment on that. These models, the models are very important. They are here, right, all over the place. You can see that in this history of artificial intelligence. Now, but this is just one way to understand the history of things, in particular here of artificial intelligence. Now, so yeah, here, so okay, something I wanted to say. Here we have to, well, so yeah, there is so the main thesis at the end of the day here is basically, so again there are more so AlphaGo, another model, and yeah, different techniques. So the pre-training techniques, different techniques Google introduced, for example, the dropout technique, different techniques of or other models, for example, deep belief networks or hidden Markov models. Yeah, ImageNet, of course. The idea of, for example, tasks, the particular tasks, for example, defeating humans at Go. Of course, these are. This is the way this. Then there are references to other things, to more abstract maybe concepts, but these are very brief references. And then, so what I wanted to say here, in the end, is that there is a kind of so again, we have the symbolic AI. I have talked about that, and the neural AI. I have also commented a little bit on that, and then this statistical AI, which again, if you there's a trend here that I want to make explicit also. It is the fact that of course we also have one way or another we are going to have a language. We are going to have mostly a mathematical language, although it can be more generally maybe logic, pure logic, and different maybe. And then inside mathematics, we have different sub branches. So, for example, the neural AI, because of the way it was presented, and it is usually understood, you are going to see a lot of graph theory, which is a subset of mathematics, let's say, or a branch of mathematics. And then we have the statistically. Here we have the finally we have the statistical, which to a great extent, statistics is a field that you can see that also in you probably see that. Of course, you also have linear algebra, but you will probably see in any lecture of this topic, particularly this one. I think we will also see that if we go to the end of the lecture, we see that at the end of the day we are going to have the statistical approaches have had the most rigor, mathematical rigor and clarity and generality, right? So sort of at the end of the day we have that statistics swallows, so to speak, or eats, so to speak, everything, all the other sub branches, so to speak. And but here there is so the implicit. I mean, I think it's quite clear also, but again, I talked about the analogy, the in the case of biologically inspired artificial intelligence. We talk about neural AI. So, but you can see here in the conclusion is that this formalist approach, which is, you could say, maybe is the most neutral approach in the sense that it is minimal. It is, we are basically at the end of the day we are always coming back to language, which I mean it presents some challenges actually. Language in itself, right? These languages are not necessarily compatible completely. Ultimately, I mean, but there is this neutral. So what I'm trying to say is that implicitly there is a thesis here in this approach, even if we have on top of the historiographic, on top of the dates and the names, and also the models, there is some implicitly there is an acceptance here of the formalist thesis, the formalist approach to understand. In the conclusions we see the formalist approach to understand artificial intelligence, which also I think here is a further comment on that. It is under a certain perspective, under a certain understanding. It is in particular my understanding. There may be others. It is also consistent with this formalist approach. Is consistent with the technical approach. In what sense? In the sense that mathematics is a technique. We understand as mathematics as a technique of representations, probably the most advanced in terms of, again, yes, in terms of rigor and clarity and precision and maybe universality. Yes, that maybe is more debatable. But there is a consistency here. Ultimately, also in the thesis, but we have to make this explicit, right? Because it's not maybe so clear. So the author of this presentation implicitly, maybe they are not completely aware of that, but because maybe they don't really care that much, or maybe they are, but they don't want to emphasize that, or they don't have time in this lecture to talk about these topics. But I wanted to make it more explicit. Implicitly, there is a thesis on top of all of these things that the author claims. Actually, there is a more fundamental thesis here, which is the formalist approach. I think if we had to classify this author and this particular presentation of the history of artificial intelligence, we will have to say that this author is a formalist. I think that is also perfectly consistent. Well, perfectly, maybe not perfectly, but it is perfectly acceptable. I think that it is not a surprise. It is acceptable that given the nature of the course, which is a course in computer science, and they talk about artificial intelligence principles and techniques. Yes, exactly. Yes. So it is more. So in particular, what I want to say here also, that I think that the author, this author, or these authors, I don't know exactly. I didn't look at that. They think of artificial intelligence more as, and I think also this is natural given the state of the field. They think more of artificial intelligence as a technique, or maybe as an engineering, more than a science. Here is the problem. We have a course in computer science. This is a problem, right? This is a problem. I think the authors here have a problem. I mean, this is a problem not of the authors, but of the field. Artificial intelligence is not a science. Still, maybe there's maybe the possibility, but here. So what? And this is maybe the most important. After all I have said, this is the most important thing in this video. As a conclusion, probably maybe we can close. This is I was a little bit improvising, but yeah, I mean it makes complete sense that we can close maybe the video here. Maybe some other comment. There is a contradiction here in the title. I mean we are trying to make all the you are looking for it a little bit, but it is there, right? We want to make that explicit. There are some principles, but those principles bring us to a certain history of artificial intelligence, which is more a technical history of artificial intelligence. We have seen that in those slides, and there is no clear conclusion inside the field of computer science, because I don't think that this is a very clear way to conclude. You are going back to statistics, but I think statistics is not the same as computer science. It is, I mean, well, you could argue, well, actually, yeah, at the end of the day, but this is a position. This is already a position. If you want to claim that computer science, maybe some people are willing to claim that computer science is nothing more than statistics at the end of the day. This is a little bit maybe we can read here. We are reading into a little bit too much into maybe, but you can see that also in the. So anyway, I think there are some many things here. Of course, the slides. This is a complex topic. The slides are only a few slides really to approach this thing. But I hope you can see a little bit what are the problems. I think we have been able to see here in an hour, a little bit improvising, just reading a little bit these slides. We see there is incapacity. I think there are some points there that need to be understood. I think it is clear that clear. We could probably everybody could agree, or most people could agree, that artificial intelligence. I think this is probably well accepted. Artificial intelligence cannot be considered a science. It is understood today, cannot be considered a science. Cannot be really. It's not just statistics. Computer science is not just statistics. The title of this course. There are some problems here. A lot of things happening here. Artificial intelligence on the one hand, computer science, artificial intelligence principles and techniques. a lot of things going on here, different things. One things are principles, another thing history, one thing here the history, many things going on here, right? So this is a problem. I think this is a problem of artificial intelligence. And so there is something to do. Again, artificial intelligence is still an early, let's say, concept. It is, as I was introducing in the beginning, it is open-ended concept. There are different perspectives. There are different ways to approach it. There is no single answer to this concept, really. But what I wanted to do here is to maybe make a little bit more explicit that here there is a type of answer, a little bit. There is a way to approach it, but maybe there are others way to approach it, right? And I have a different way to approach it, and that is what I offer in my lecture that I was talking about before, and I referenced in my previous video. And finally, I wanted to say, there is a chaos here. So, actually, the author, even at the end of the day, they're maybe honest, and they say they accept a little bit. I think they accept this problem. They say AI is a melting pot that has drawn from many different fields, ranging from statistics, algorithms, neuroscience, optimization, economics, etc. So, AI is a melting pot. This is a little bit like the chaotic thesis. Let's say at the end of the day, this author is a little. I think he is. It's a little bit of a joke, but I think this author maybe is a little bit of an anarchist. There is a little anarchy here in this professor. There is the chaos of artificial intelligence. Everything is a melting pot. Everything here happening all together, all the time, and this is. This is a way to approach it. The anarchist. I'm not in particular against anarchists, and this is one way to approach it. There's an anarchy here, and we are trying to solve real-world problems. That is fine. You can do that. Maybe you can do that. Now, we have to be more. If we want to be more rigorous, if we want to do some science here, because at the end of the day we are talking about computer science here, right? Computer science 221. I think we have to try harder. And again, I don't want to criticize in particular this course, because I understand this is just an introduction to the history of artificial intelligence, and this course is not about the science, or it's not about a history of the science, it's not about a history of artificial intelligence, right? This is just an introduction. But it is useful, I think, to see. Probably, if you go to other fields, if you go to other, you can see more order. Maybe if you have a history of physics, it's probably more boring. There is no anarchist thesis at the end of the day, probably, because physics, I think, is more boring. Because physics, it depends on what branch of physics. Maybe many things going on in physics. But if you look at a history of physics, it's definitely more boring than a history, because things are already pretty much established in many ways. Artificial intelligence is much more new. Many things going on. It is true that it is a little bit chaotic. So in that sense, it is okay. But so, I wanted to talk about this, I wanted to make explicit, and I wanted to say there is room for science. There is more room for science. There is more room also for maybe more a different perspective, and I think a better history of artificial intelligence. I think there is room for a better history of artificial intelligence, more principled history of artificial intelligence, and that is what I offer. I am offering in my lecture. You can go here to my website, Torbellino Tech, Torbellino, TORBELLINO.tech, and you can go here to education consulting, and at the end you can see here my lecture 1, first lecture, historical definition of artificial intelligence. And I write here. I wrote it this a few months ago. Let's read it again. I don't remember exactly what I wrote. Artificial intelligence, in its most general sense, is an ambiguous term. It asks for clarification and allows multiple definitions. Exactly. In this lecture, lecture 1, I introduce thesis 1, the historical thesis. I am explicit that I have a thesis. I mean, well, this is one thesis. It is here. The author is maybe, well, it's a little more chaotic, the author himself, and there is a chaotic thesis, maybe a little bit. And I am more clear here that I have a position, or well, this lecture in particular. It's not that I have it. It's just this lecture. I happened to offer this lecture. And I say here, I connect 4 domains of knowledge to provide a historical definition of artificial intelligence. I provide a specific connection of these 4 domains. This is, I have not seen this, another thing I wanted to emphasize, I have not seen this anywhere. I have read, I'm mentioning here these slides. I have read many other stories of artificial intelligence in the last decade, let's say, or so, or the last 5 to 10 years. And after all those readings, among other things, I have come to some interesting approach to the history of artificial intelligence. There's a specific way, a specific approach, a unique approach. I attempt to situate artificial intelligence in universal history. This is also another thing. So here the author a little bit talks a little bit. What do I mean by universal history? Well, universal history. So, for example, here they talk about Aristotle, which is traditional, historical, right? This is maybe Aristotle is in the universal history of philosophy, you could say. There is maybe a little bit of an attempt of the author, or maybe they simply didn't have the time or the interest. But so universal history is more about ideas, right? At the end of the day, we are trying to derive some main trends, main ideas, not only about artificial intelligence. Here we have some concepts, some history of artificial, some main trends. But here I connect those. I connect a little bit that with other ideas of universal history, let's say. Well, I cannot explain too much. If you want to know more, you can contact me here. Also, there is a contact section. Maybe I'm able to explain a little bit more what this service is about. Because I understand this is a quite a specific service, maybe for a specific restricted set of people. But I think I hope with what I have been talking about, you can see better, or maybe what are the problems there, or what can be done a little bit, and maybe you become more interested on that. Yeah, well, I talk a little bit about artificial intelligence and cybersecurity. Yeah, anyway. So, yeah, I think that is it. Well, that actually was a lot. I wasn't expecting this video to be that long. But yeah, I was a little bit slow. I was improvising a little bit. I was a little bit slow in dealing with some of these slides. But yeah, I hope it was more or less clear, the main ideas. In the end, I think it was better. The conclusion of the video, I think it was better, and I was able to present the main claims I want to make, and to connect that with my lecture here, my historical definition of artificial intelligence. And yeah, that is it. This is also, I say here, just to finish, this is just the beginning. Yeah, I think so. I think this is just the beginning of artificial intelligence. See you.